For generations, humans have always tried finding a method of measurement that is completely accurate. That is where white light scanning comes in, the newest innovation in the field of measurement. Although it is not completely accurate, it is remarkably close, acting as one of the most precise measurement tools yet. Its precision accuracy is up to less than 0.001 of an inch in smaller volumes, and 0.003 of an inch in larger ones. The white light scanner measures the physical characteristics of an object with the use of an optical measuring system known as interference. With the combination of 3 different cameras pointing light rays towards the object, thousands of points are processed through a computer, creating 3-dimensional models. As shown in this diagram, the separate light rays produced from the LED cameras converge and are then refracted through the collimating lens. These lenses enforce the rays to stay parallel from one another. As these rays continue to travel, it hits the beam splitter where the refraction occurs. Due to refraction, the light rays change directions, with some being redirected towards the reference flat, and some redirected to the mirror in front of the CCD camera. Here, these light rays are then reflected back. They then meet back at the beam splitter. Here the rays combine, increasing in power and intensity, creating an interference pattern directed back out the beam splitter. This then forces the beam to refract and redirect towards the specimen. Once the interference pattern is placed on the object, the rotating plate under the object starts to rotate. The interference pattern continues to hit the object, targeting and locating points. During this, an attached camera also takes various pictures of the specimen. In a few seconds, thousands of points are selected, and by reconstruction, these points are put together to create a model. This replicated model is then able to be toyed around with for adjustments. Here is a white light scanner in action. Prior to the 19th century, measuring tools started off with using body parts such as feet or hands. However, with progression in the 19th century, France decided to create the world's first measurement unit, the meter. This came along with rulers, meter sticks, measuring tapes, and scales. Fast forward to the 20th century, and our knowledge has advanced to a point where science of optics and computing reached the point where lasers were used to make measurements more accurate than ever. With this came the most recent innovation of using light as a measuring tool, white light scanning. It was created by multiple engineers with the purpose of creating an optical instrument more accurate than the common laser scanning. In this case, science was used to solve the need for measuring accurately. Through the knowledge of optics and triangulation of light and distortion, we have progressed the field of measurement. Economic impacts. Instead of traditionally having to create plasters, molds, or any objects to create accurate measurements with white light scanning, many industries save money and time 3D modeling. It is proven to be economically resourceful for many industries around. In production and engineering, it is used for accuracy and precision in producing engine blades, part moves, and sheet metal cuts. In dentistry, it is used to plan surgeries and train dentists with 3D models. It is also used to produce detailed and accurate topographic maps. Political impacts. Though the scanner is remarkable in its accuracy for measurements, politically, this device is not suitable for all industries. This optical device costs a pretty penny. A good quality scanner can cost $9,000 and above. This expensive tool is not accessible for everyone, which is why its popularity is low for many industries. In conclusion, this fascinating optical instrument really is a step into the future due to its non-contact, accurate measuring, but like all advanced technology, higher prices follow suit, putting a restriction on its success and popularity of this optical tool.